Okay, Neil, we can see you coming down the ladder now.
In July 1969, humans landed on the moon. That is the story we all know. But there is far more to the Apollo program than that single giant leap. What many people do not realize is that NASA successfully carried out 6 crewed moon landings in just 3 years. Think about that for a moment. 6 crewed lunar landings in 3 years, something that would feel almost impossible by modern standards. So what were they actually doing up there? Apollo 12, the second crewed mission to the moon, came just months after Neil Armstrong's first historic step. It was November 1969. Charles Conrad, Richard Gordon and Alan Bean climbed aboard their Saturn V rocket for humanity's return to the moon. But this mission was far from smooth. Apollo 12 carried ambitious goals. The crew brought a state-of-the-art color television camera to broadcast live from the lunar surface, a major upgrade compared to the grainy black-and-white images from Apollo 11. This mission also served as a critical technical test for NASA. The first moon landing had succeeded, but only narrowly. What most people never realized was that Neil Armstrong and Buzz Aldrin had been off course during their entire descent. They overshot their intended landing site by several miles and ended up touching down in what was essentially an unplanned location. So what NASA needed to prove with Apollo 12 was that they could land a spacecraft precisely on target. This was essential for any serious scientific exploration on the moon. To do that, they chose a familiar destination. The Surveyor 3 spacecraft, a robotic lander that had touched down on the lunar surface 3 years earlier in 1967. The mission of Apollo 12 was simple in concept, but difficult in execution: travel to the moon and land close enough to Surveyor 3 to inspect it directly. But almost immediately the mission ran into trouble. Their Saturn V rocket lifted off in the middle of a thunderstorm. These were far from ideal launch conditions, yet NASA was under intense pressure to proceed. President Richard Nixon and his wife were present in Florida to witness the launch, and everyone understood that if they missed this window, it could take months before another opportunity to reach the moon. The rocket disappeared into thick clouds above the launch pad. Just 36 seconds into flight at an altitude of over 6,000 feet, Apollo 12 was struck by lightning. The strike instantly disrupted the spacecraft's electrical systems. Warning lights flashed across the control panel. Mission Control lost communication with the rocket, and the 3 astronauts on board were left in complete uncertainty. Then, just 16 seconds later, lightning struck again. Now at an altitude of 14,000 feet, the rocket had lost its main power. Its guidance systems were failing, and it was racing toward a potential catastrophe at incredible speed. It was quick thinking on the ground that saved the mission. A flight controller had seen a similar electrical failure during a training simulation, and he sent a now famous instruction to Apollo 12. Pry SCE to auxiliary. That command switched the signal conditioning equipment into backup mode, restoring power and bringing the spacecraft systems back to life, allowing the mission to continue. That moment marked the last time NASA would ever launch a rocket during a thunderstorm. After narrowly avoiding disaster, Apollo 12 went on to achieve something remarkable. A near-perfect landing on the edge of the Surveyor crater, just 180 meters from the Surveyor 3 spacecraft. Back on Earth, millions of people tuned in to watch the first color television broadcast from the moon. What they witnessed was extraordinary. The second group of humans setting foot on the lunar surface. But the broadcast did not last long. Just minutes into the moonwalk, Alan Bean accidentally pointed the camera directly at the sun, with no atmosphere to filter the light. The intensity instantly destroyed the camera's delicate internal components, ending the broadcast almost as quickly as it began. Still, the mission itself was far from over. The astronauts successfully reached Surveyor 3 and removed several components to bring back to Earth. These became the first man-made objects ever returned from a long-duration stay beyond our planet. Apollo 12 also deployed one of the most important scientific systems ever placed on the moon. The Apollo Lunar Surface Experiments Package, This was a sophisticated set of geophysical instruments designed to continue monitoring the lunar environment long after the astronauts had left. This package included something known as the lunar seismic experiment, essentially a seismometer designed to detect earthquakes on the moon, or what scientists call moonquakes, to test it. NASA decided to create a moonquake themselves. After the astronauts lifted off from the surface and returned to the Apollo command module in orbit, the lunar module was deliberately sent crashing back into the moon. The instruments recorded the vibrations from the impact, and what scientists observed was unexpected. The reverberations lasted for nearly 1 hour. It was often described as the moon ringing like a bell, a discovery that revealed just how unusual the moon's internal structure really is. Then came Apollo 13. Often remembered as the most dramatic mission of the entire program. About halfway to the moon, an electrical failure inside the service module caused an oxygen tank to explode, placing the crew in immediate danger. Once again, millions of people around the world watched as events unfolded in real time. But this time the outcome was uncertain. Every mission to the moon carried risk, but Apollo 13 made that danger impossible to ignore. The crew survived. But the incident changed how both the public and the government viewed lunar exploration. Despite this, NASA moved forward. Apollo 14 would become America's return to the moon. Nearly 1 year after the crisis of Apollo 13. To lead this mission, NASA chose one of the most experienced figures of the space era, Alan Shepard. As the first American to travel into space, he was now preparing to walk on the moon. At 47 years old, Shepard was the oldest astronaut in the Apollo program, and his experience would prove critical to the success of Apollo 14. As had almost become expected by this point, the crew faced a serious problem on their way to the moon. When the Saturn V rocket launches, the lunar lander is stored inside a protective section beneath the crew capsule. But before the astronauts can descend to the lunar surface, the command module must separate, turn around in space, and dock its nose into the airlock of the lunar lander. This maneuver had to be performed manually by the command module pilot. With limited electronic assistance from a docking probe, when Apollo 14 attempted this critical step, the command module failed to latch onto the lunar lander. They tried again and again, 6 times in total, but each attempt failed. At that moment, the entire mission was at risk. Commander Alan Shepard remained calm. He made the decision to switch off the electronic probe and rely on manual control. The pilot aligned the spacecraft by sight alone, guiding it into position with precision, and this time it worked. The docking was successful. Apollo 14 would go on to achieve the most accurate landing yet, touching down just 87 feet from its intended target. Alan Shepard may not have been the first person to walk on the moon, but he became the first to play golf there. Before the mission, he had attached the head of a 6-iron club to one of his tools and secretly brought 2 golf balls with him. Standing on the lunar surface, in front of a live camera, Shepard took his swing. His bulky spacesuit limited his movement, and after an awkward first attempt, he struck the second ball cleanly, sending it drifting across the moon. Shepard later claimed it traveled for miles. In reality, it went about 40 yards. But that moment of humor and humanity was exactly what people on Earth needed. Apollo 14 restored confidence in NASA's ability to land on the moon. It also laid the foundation for a major leap forward in exploration. Apollo 15 would take everything learned from earlier missions and push it further, introducing longer stays on the surface and more advanced geological research. Astronauts could now spend a full 3 days exploring the lunar surface, thanks to an upgraded life support system built into their lander. To take full advantage of that extended time, NASA introduced the Lunar Roving Vehicle, a battery-powered electric rover designed for mobility across the Moon. It could reach speeds of about 15 kilometers per hour and travel roughly 90 kilometers on a single charge. With this vehicle, the Apollo 15 crew explored mountain ranges and ancient lava plains, dramatically expanding the scope of lunar exploration. During these excursions, they collected a remarkable sample later known as the Genesis rock, a piece of material estimated to be about 4.1 billion years old, dating back to the earliest formation of the solar system. The astronauts also carried out a simple but powerful demonstration of Galileo's theory of gravity. They dropped a feather and a hammer at the same time onto the lunar surface. Centuries earlier, in the 16th century, Galileo had shown that objects of different masses fall at the same rate under gravity, with air resistance being the only factor that can alter that motion. On the Moon, where there is no atmosphere, that effect disappears completely. As a result, the feather and the hammer fell at exactly the same speed, confirming the principle in one of the most iconic experiments ever performed beyond Earth. 10 months later, in April 1972, Apollo 16 arrived on the Moon. Once again, equipped with the now proven lunar roving vehicle, their mission focused on exploring the lunar highlands, a region once believed to have formed through intense volcanic activity in the Moon's distant past. Among the crew was Charles Duke, who had supported the first moon landing from orbit while Neil Armstrong and Buzz Aldrin descended to the surface. Now it was Charles Duke's turn to pilot the lunar lander and leave his own footprints on the Moon. What the crew discovered there was unexpected. The highland region, long believed to be shaped by volcanic activity, turned out to have a very different origin. Their investigation showed that the terrain had actually been formed by massive asteroid impacts that pushed the surface upward over time. This finding became a major step forward in understanding how the Moon formed and evolved. Another detail that stood out from Apollo 16 was the crew's description of lunar dust. They reported that it felt greasy against the skin and carried a smell similar to gunpowder, a strange and memorable characteristic of the Moon's surface. In December 1972, it was time for what would become the final moon landing of the Apollo program, Apollo 17. By then, public interest and political support for lunar exploration had begun to fade. Even so, NASA assembled the most advanced and scientifically ambitious human space mission ever conducted, a record that still holds today. Apollo 17 was also unique because it marked the only time a professional scientist walked on the Moon. While all previous missions carried out scientific work, every astronaut before had been a military test pilot trained to perform experiments. Harrison Schmitt was different. He was a trained geologist who had also qualified as a lunar module pilot. The mission landed in a region known as the Taurus Littrow Valley. The site was surrounded by low mountains and steep cliffs, exposing layers of ancient rock from deep within the Moon's crust. Apollo 17 became the longest stay on the lunar surface, with Schmitt and his commander spending a total of 75 hours there. Of that time, 22 hours were spent performing extravehicular activities on the lunar surface. Once again, the rover played a critical role, allowing the astronauts to travel more than 36 kilometers across the Moon and reach distances over 7 kilometers from their landing site. One of their most surprising discoveries was that the Moon is not entirely gray and colorless. Harrison Schmitt uncovered patches of orange soil hidden beneath the upper layer of dust. When these samples were brought back to Earth and analyzed, scientists found that the material contained tiny, brightly colored spheres of volcanic glass, formed around 3.6 billion years ago. In total, Apollo 17 returned 741 individual rock and soil samples, with a combined mass of 110 kilograms, the largest collection ever brought back from the Moon. These samples became the foundation of our modern understanding of the Moon's volcanic history and the early formation of the solar system, but Apollo did not end in the 1970s. More than 50 years later, scientists are still studying those same lunar samples with technologies the Apollo era never had, revealing new details about the Moon's evolution and even reshaping what we know about ancient impact events that may have shaped both the Moon and the early Earth. In a very real sense, Apollo did not just explore the Moon. It brought back a scientific archive that is still producing discoveries today. And now, after more than 50 years, humanity is preparing to return through the Artemis Program, guided by those same samples and lessons. But this time, we are not going back just to visit. Artemis 2 is not about landing. It is about reopening a path that has been silent for half a century, the first step towards staying, building and learning how to live beyond Earth. Orion is not Apollo. It does not rely on fragile analog systems or constant instructions from the ground. It can navigate, adapt, and protect its crew with a level of autonomy that once belonged only to theory. This mission is not repeating history. It is redefining what it means for humans to exist in space. And yet one thing has not changed. As the spacecraft passes behind the Moon, the crew will disappear from Earth for around 40 minutes. No signal, no voice, no connection. Just 4 humans suspended in deep space, exactly as Apollo crews once were. Only now the silence carries a different weight, because when they emerge from the far side of the Moon, they are not just returning to Earth. They are proving that the next time we go back, it may not be to leave. By this point, NASA recognized that the Apollo program was coming to an end. Although there was still hope that humans would return to the lunar surface in the not-too-distant future, it was clear that Apollo 17 marked the close of an extraordinary chapter. Mission Commander Eugene Cernan would become the last human to stand on the Moon. In his final moments before leaving the surface, he spoke words that would echo far beyond that mission, with peace and hope for all mankind.